G'day, you're watching Miss Hobbs Teachers, and today I'm going to be teaching you chemistry, and we're going to be learning all about the different factors which affect the rate of reactions. Okay, awesome. Let's get into it. So before I start, I'll introduce myself. My name's Miss Hobbs. I am a science, STEM, ag and business management teacher from Victoria. So what we're going to be talking about today is Victorian curriculum aligned. So reactions. We've got all different types of reactions, okay? They can be either physical or chemical, okay? Now, a physical reaction, we see a change in things like odor, shape, color. But importantly, with a physical reaction, we don't see a change in the molecular structure or the bonds, right? Chemical change, we see something new produced, and we see those changes, okay? That's that real distinguishing factor. So have you ever put some polystyrene in with acetone nail polish remover? You would have seen that the polystyrene cup, it actually shrivels down and comes really floppy. It changes texture. That's a physical reaction, okay? We haven't formed anything new. That's physical. What we're going to be talking about today are chemical reactions, okay? Now, chemical reactions are a really nice one that you'd be super familiar with like every day is things like airbags going off, all right? Your airbags are tucked away, you can't see them, but upon impact, upon collision, we see the airbags, they expand, and that's because we've seen a chemical reaction within our airbags which have caused them, okay? So in a chemical reaction, really important to distinguish it first before we get into what affects it, because otherwise if you can't distinguish, how do you know the different factors, right? So distinguishing, you're going to have a new product produced, okay? You're going to have the same reactants but new product, and that's what's going to make a chemical reaction. Is everyone happy with that? That's some 8th grade chem there. Yeah, we're happy with that. Okay, so you've got a few different factors which are going to influence the rate of reaction, okay? So you've got the surface area of solid reactants, okay? The greater the surface area, the more easily, okay, and the more quickly your products can react, okay? You've got the concentration of the reactants that are in your solution. That's going to affect the speed of your reaction. You've got things like gas pressure, temperature, alongside the presence of catalysts. And these are the things that we're actually going to be talking about today and going into in a little bit more detail. So let's start with surface area, okay? So surface area can have a really big impact on the rate of your reaction. Okay, so if we are talking about surface area, the smaller the particle, okay, a smaller particle that has the same mass as a larger particle is going to have a bigger surface area, okay? That's what you need to understand first. Now, the bigger the surface area, the more quickly our reaction is going to occur. So surface area increases, reaction rate increases, all right? So a nice example of this is, we know fireworks, you've all seen them, right? Aluminium is actually used in fireworks. Now, if we have really small pieces of aluminium, it is going to explode crazy, like super, super, super quick, right? We don't really want that for fireworks. We're gonna want a slower reaction. It's still going to be fast, right? But we're going to want it to be slower because we want the sparks. So if we have larger pieces of aluminium, yeah, then we are actually going to see those sparks and the nice, pretty colors. Yeah. So that's an example of how we can use the rate of reaction, understanding that principle to our advantage. Okay, concentration. So the higher the concentration, the faster the rate of reaction. So a nice example of this is, when we're driving around cars, we release pollutants. So things like carbon dioxide and sulfur dioxide, nitrogen dioxide, those two, sulfur dioxide and nitrogen dioxide, when they're released, okay, they're actually going to react with water, okay, with dihydrogen oxide. Now, when these react, okay, we see a decreased pH, which means an increased acidity, okay? That increased acidity leads to what we know as acid rain. Now, the Industrial Revolution is a point in time when we've started seeing, these compounds released more and more, and therefore the acidity increased or pH decreased, yeah? Since then, okay, the last 200 years, we've actually caused a lot of famous marble statues to disintegrate more rapidly than they usually would have because of acid rain, right? Because of the water cycle, we know that we have the condensation and precipitation, but then we also have it leaving and we've got it going back up, right? So then it becomes a continual cycle, yeah? So we've increased the rate of reaction through increasing concentration, okay? So increasing the concentration, like acid rain, is going to increase the rate of that reaction happening, and that reaction is the dissolving of marble statues. Now, in reactions involving gases, we know that pressure positively correlates with reaction. So when we increase pressure, we increase the rate of reaction. Now, the reason when we increase pressure, we increase reaction is because we are causing the particles to become closer together, okay? So think about it like this. You're putting helium into a container, into, your helium bottles, whatever. You're putting it all in there. Even though we can't see the helium, we know it fills up because it gets heavy and we've pushed lots of particles together. So when we increase the pressure, we would also in turn increase the rate of reaction when we're involving gases, okay? Because we're putting more and more particles into that same space. So this is sort of underpinned by this concept called particle theory, which basically says that the more particles we put in there, the more collisions they're going to have, okay? So as we put more and more particles in there, they're not going to have as much space to bounce around, so they're going to be hitting each other with a higher frequency, okay? And when they're hitting each other with a higher frequency and bumping into each other lots and lots and lots and lots and lots, it's going to increase the rate of our reaction. Yeah, you see how it's like a bit of a perpetuating cycle there? So, increasing pressure increases the rate of reaction. Now, I want you to think about when you're baking a cake. You're baking a cake, you pop it in the oven, and then it makes your cake, okay? You've got your wet ingredients together, you've got your batter, you pop it in the oven, it makes a cake. Just like all the others, temperature positively correlates with reaction. So when we increase pressure, increase temperature, we're increasing the rate of reaction. Also when we increase pressure, also when we increase concentration, and when we increase surface area, okay? The reason why temperature increasing is also going to increase our rate of reaction is because we are heating up our molecules or particles, right? And then our particles, because they're heating up, they're going to move more because they've got more energy than what they would have if they were just at the room temperature or whatever, yeah? The final thing is catalysts, okay? When we add a catalyst to a reaction, we increase the rate of that reaction. So I want you to go and try this. Grab yourself a regular plain biscuit and I want you to chew it. Now, as you're chewing it, don't swallow it, just keep chewing it. A little bit gross, but just keep chewing it. As you're chewing it, you'll notice that it starts to become sweet. That's because of the catalyst, which is present in your saliva, is helping to break down that biscuit, okay? And that actually creates a sweet taste in your mouth. So, when we've talked about all these different ways that we can increase reaction, we can increase reaction by adding a catalyst. We can increase the rate of a reaction by adding or increasing our temperature, by increasing our pressure, by increasing our surface area, or by increasing the concentration. All of these things will increase or speed up our reactions. Now, we've talked about how we can speed them up. How can we actually measure them? We measure the rate of a reaction by looking at the change in concentration of the reactant or product, okay, per unit of time. So that's how we measure rate of reaction. It's the change in concentration of your reactant or product per unit of time. Okay, so let's just summarize what we've talked about here. We've talked about that the rate of a reaction, okay, is the change in concentration of the reactants or products over time. Really nice and succinct. Write that one down. We've talked that the rate of a reaction can be increased by increasing surface area, by increasing concentration, by increasing pressure in gases, by increasing the temperature, or by adding a catalyst. And the 5 key ways. So given that we know these 5 factors, okay, influence the rate of reaction, and that we can define the rate of reaction as changing concentration of the reactants or products over time, it means that we can actually measure this changing reaction if we can measure mass, so mass loss, okay, or mass change, if we can measure the volume of gas that's produced, if we can measure color change, or pH change, right? Or if we can measure concentration change. So there are the mechanisms by which we can measure the rate of reaction. Thanks for watching this episode of Miss Hobbs Teaches Chemistry. You should know the influences on the rate of chemical reaction. If you want to trial out your knowledge, see how much you learnt, you can download the worksheet for this lesson, which is on my Teachers Pay Teachers store, which the link is down below. Make sure to give this video a thumbs up if you found it helpful, turn the notification bell on if you would like more of these, and comment on the next topic that you would be keen in covering. I hope this was a help. I'll be doing a few of these over the duration of Victoria's lockdown, so stay posted. Thanks for watching, guys.